Before we start, we'll list some of the perfect squares on the right side. 1 squared equals 1 isn't really of any help to simplify a radical, so we'll leave it off the list. So the square root of 4 is simply on our list. If we look at that and we get a 2 and it's brought outside. So let's say that I had the square root of 20 that's inside. Well, the square root of 20 isn't a perfect square that's on our list. We skip over it going from 16 to 25. But what we can do is rewrite the 20 inside to be the square root of 4 times the square root of 5. When we do this, we can take the square root of 4 out, and that would give us 2 square root of 5. Let's try square root of 160. Well, 160 is not a perfect square, but we can rewrite it as 16 times 10. And the square root of 16 is on our list. We see that it's a 4, so we can take the 4 out, and that leaves us with the square root of 10. Now, there's no factor of 10 if I list them, 1 times 10, 2 times 5. There are no factors that are perfect squares that are left underneath, so this one's simplified. With the square root of 72, what I'm going to do is I'll give you a procedure that'll always work. And if I write the factors of 72 over here, so obviously we have 1 times 72, and we have 2 times 36. Well, I immediately notice when I'm listing the factors that 36 is a perfect square. So I'm going to rewrite this as the square root of 36 times the square root of 2 underneath. And the square root of 36 is 6, and what's left underneath is the square root of 2. So let's use that newfound procedure to do 180. So I have 1 times 180. I have 2 times 90. I have 3 times 60. Still no perfect squares. And I have 4 times 45. And then I have 5 times 36. And finally, we've come to a perfect square. So I rewrite the square root of 180 as 36 times 5. 36 is a perfect square. I can bring the 6 outside, and radical 5 stays inside. So let's raise the difficulty level a little bit. This is an algebraic square root. What I want to do is look at each piece of what's underneath to see if they're perfect squares, and that can apply to the x's too. What I'm going to do is I'm going to rewrite this. The 8 is 4 times 2, and the x is x times x. The x is a perfect square. I can bring the x out, and the square root of 4 is 2. So I can bring out the 2, so the 4 is gone. And then the two x's, x is a perfect square, so I can bring out that x. And what's left underneath is just radical 2. And this is our final answer here. This looks rougher than it really is, and I just follow the same procedure. Just do one piece at a time, and you can do it. So I'm going to list the factors of 147. So I have 1 times 47, no help there. It's not divisible by 2 because the last number is not an even number, so this is out. And then the next is 3, and when I divide 147 by 3, I get 49, and 49 is a perfect square. So going back to this, I'm going to write it in expanded form. So the 147 is 49 times 3. Then I have x to the third power, which is x squared times x to the first power times y squared. Well, now I can take out the pieces that are perfect squares. The square root of 49 is 7. That's out. The square root of x squared is x, so I can bring that out. This x will stay underneath, and the square root of y squared is just y. And then what's left underneath the radical is 3 and x. So just write that, and this whole thing is the answer. There's a couple things different on this example. Inside, we're just going to review the exponent rule. This x here is, when I multiply x squared times x squared, what I'm doing is, a bad example, but x, because you can't tell, I'm not multiplying the exponents, I'm adding them. So if I have x squared times x squared times x squared, I just simply add the exponents, so this is x to the 6th. So what I have here is 3 x squareds in expanded form. Let's just write that out so we can see it underneath and then take the pieces out one at a time. So what I have under here, square root of 4 is a perfect square. And then the x to the 6th power is x to the 2nd times x to the 2nd times x to the 2nd. And then the y is the same thing, y squared times y squared times y squared. And then I can take the pieces out. So the 4 comes out to be a 2. I have an x squared to begin. And then I have 3 x squareds underneath, and each one of them comes out as an x. So this x squared is 1x, another x, another x. So I'm actually going to be taking out x to the 3rd power. I'm dividing by 2. So when I take out x to the 3rd power and I multiply x squared times x to the 3rd power, what I get is x to the 5th power. And then over here, I'm taking out y squared, y squared, y squared, and that's 3 of the y's come out, which is y to the 3rd power. And I took out the 2, so what's left underneath is absolutely nothing. So what you have is something that looked really ugly at first, and this is the finalized answer. Let's try a few more. Okay, on this one, we're going to look at a shortcut instead of expanding this to be x squared, x squared, x squared. What I'm going to do is give you the shortcut. And we start off with this one. Let's bring down the 3x to the 3rd. We come off to the side. We have 1 times 108 to find the factors of 108, 2 times 54, and then 3 times 36 will work. And 36 is a perfect square. So when I expand what's underneath, I'm going to have 36 times 3 times x6 and y8. Now, when I do this, I'm going to bring the 36, the 6 comes out. This would become an 18, because this would be 6 times, it would be 6 times 3, so it's 18x. And when I bring this out, what I do is I divide the exponent by 2, because every 2 is going to be one perfect square that I can take out. And when I do that, this becomes x to the 3rd comes out. Well, x to the 3rd is already out. I'm going to add the exponent, so this becomes x to the 6th. And then for y to the 8th, what I'm going to do is I'm going to divide by 2, so y to the 4th would come out. So what's left under the radical is simply square root of 3. This is the final answer. Let's take a look at this y to the 8th power. So each one of the y to the 8ths is y squared times y squared times y squared. One more y squared. And then when I take each one of these y squareds out, it's y, the square root of y squared is y. And I'm going to do that 4 times. And these all have an exponent of 1. I simply add them together, and that's where I get the y to the 4th. So the shortcut is to simply divide the exponent by 2. You get y to the 4th, and that's y to the 4th is the square root of y to the 8th. So on this one over here, I see what's underneath. I'll just bring down 7x squared y to the 3rd, and then I'll expand what's underneath. 63 is 9 times 7, 9 being a perfect square. And then the x to the 4th is going to be a perfect square. X squared times x squared is x to the 4th. And then y to the 3rd is y squared times y to the 1st power. So I'm going to bring out the pieces. So when I take out the 9, it's a 3, so this becomes 21x. And when I take out the x squareds, it's x and x. So this out here is x squared times x squared, which is x to the 4th. And then I have y to the 3rd, and I'm taking out a y squared, which is a y to the 1st power. That increases the y up 1. And then what I have underneath is just 7 and y. The last thing that might come up is if you have a negative under the radical, and we need a definition. The square root of -1 is an imaginary number, and we simply call it I. So if I have a negative under the radical, when I bring it out from under the radical, I would have the letter I in the answer. So the square root of, if you think about this, the square root of 2 times the square root of 2 equals what's under the radical, so we just get a 2. And the square root of -1 times the square root of -1 is going to equal -1. So when I take the square root of -1 and I get this letter I, that'll be in the answer. So let's look at one example of that. So in this example, I have the negative that's under here. I'll write it in expanded form. So I have the square root of -1 times, and then 125 is 5 times 25. So I'll put the 25 first, times 5, and I'll leave the x to the 5th like that so we can use our shortcut rule. When I take the -1 to the outside, I'm going to have an I, and when I square root of 25 is 5. So far I have 5I, and the square root of 5 I divide by 2, and what I get is x squared with 1x staying underneath. So the final answer underneath would be 5x. And if you're still not fully understanding this, x to the 5th is x to the 4th times x to the 1st. Well, x to the 4th comes out as x squared, which is over here, and an x to the 1st power would remain underneath.